All right, IbB AA SL2 kids. We are coming close to our first test. That first test will be on just sections 5.1 and 5.2. This is an activity I call closure notes. It's sort of a laundry list of everything that could pop up on an assessment. I'm not saying that every single one of these things will pop up on the assessment, but they could. I just don't want there to be any surprises. The first thing we started talking about in this class were limits. One thing you should know is the limit notation. Like if I write something like this, limit as x approaches 5 of x squared plus 2, that you can figure out what that limit is, or you know what it means to approach 5 with the function x squared plus 2. Remember that anytime we write something like this, that means approaching from both sides, unless they specifically specify, as x approaches a from the right, or x approaches a from the left. Be careful that sometimes we can have holes in graphs. Holes in graphs are usually where there's a divide by 0 happening, or when an x tries to divide by 0. Or they might just tell you straight up, like, hey, x cannot equal 2 in this sort of function. But usually there's a reason like that you can't divide by 0. Also be comfortable with this sort of notation for horizontal asymptotes. We did do a little bit of finding horizontal asymptotes with rational functions. Remember that the horizontal asymptote from the actual equation is just the ratio of the leading coefficients, only if the degree of the top and the bottom match. Then the big topic in this unit has been derivatives. We did do a few problems doing the difference quotient. So the difference quotient is this big formula right here. Remember that it's essentially comes from slope, that this is kind of like a rise over run, that's a rise, like f of x plus h minus f of x, and then the run is on the bottom, which is h. You're sort of doing that as h approaches 0 because you're turning a secant line into a tangent line with a limit approach. Then we quickly shifted gears and learned about the power rule. Remember that the power rule is very simple and fun if you have it in the right form. But sometimes it's not in the right form. Sometimes there's like an x in the denominator or something, and that's where you have to do a quick rewrite to be able to do the power rule. Remember, it has to be in the form of ax to the n. Then we did some smaller derivative rules, like the derivative of a constant is 0, or the derivative of a linear, like 5x would just be 5 or something like that. They're not quite like official derivative rules, they're just kind of like these smaller applications of derivatives. This might seem confusing, the sum or difference of functions, but that literally just means something like if you have f of x is equal to x to the 5th plus x squared, that the derivative would just be doing the power rule of both parts. That it would be 5x to the 4th plus 2x. The last topic we did in this unit was the equations of tangents and normals. Remember that tangents and normals are always going to be in this form, y equals mx plus b, where m is your slope or gradient, and b is your y-intercept. Remember that derivatives are just slope machines. So if you take a derivative, that machine gives you the slope of tangents at any point on the curve. We might ask you to find specific slopes, like, tell us when the tangents on this curve have a slope of 5. That usually involves, well, I'm not going to say that. I'm going to say that for a second part. Well, no, that would involve, usually this involves solving a quadratic of some kind. We also might ask you to find some horizontal tangent lines. So horizontal tangent lines have a slope of 0. So you set the derivative equal to 0 and try to solve. Once again, that usually involves solving a quadratic. So know your factoring techniques. simple factoring, perhaps even a smoke and mirrors if you were a jolly student last year. If you don't know what smoke and mirrors is, do not try to Google it. You'll come up with nothing. You'll just see a bunch of sites about old-timey magic. But if you ever want to know the smoke and mirrors process to factor something, say like 3x squared plus 8 plus 10x, something like that. If you don't know how to factor that without guessing and checking, come hit me up. I can show you how to do it. All right. Good luck.